Alright, hello everybody, my name is Jaren, and today we're going to be doing a tutorial with FreeCAD, which is a parametric modeler. We're going to make a couple of objects that can then be used to either 3D print or send to a machine shop or something like that. So various things like that. This is a very intro tutorial, so it'll be more or less covering creating sketches, extruding those sketches, or revolving those sketches as we call it. So let's get into it. So you're gonna open your FreeCAD, whatever way that may be. Maybe you have an icon down below or something like that. Open it up, brings you to the start page. So up above, this kind of gives you all your tools. Let's start to create a new document. That brings this up. You can name it or save it, whatever you want. So let's so make your folder and save it whatever you want to save it as. So I've saved it as TUT1, tutorial for short. Yes, and so once you've got that, kind of give you a description of this. So up here, if you can see my mouse there, these are all the tools that you're going to, this is where you're going to find all your tools. Initially in the start, you can kind of just view objects. Down on the right side of your page here, you've got your axes indicator, so it kind of indicates where you are in space. So if you rotate, also to change navigation styles, which is how your object moves when you click mouse buttons. The inventor navigation, I believe with the left button click you can rotate. It might be easier if I actually have something here to rotate about. So I'll just open something up here. So this is a basic thing here. So the one I use the most is CAD navigation. So your mouse, I recommend using a mouse. This is going to be nearly impossible to use with a touchpad. So get a mouse with obviously a left and a right click and a middle scroll wheel, especially one that clicks. So with the regular CAD navigator, clicking and holding the scroll wheel, which is the thing between the two buttons, should bring up that thing there, and that allows you to move the image side to side or up and down without rotating or anything like that. So holding that to moving your mouse around moves it side to side, up and down. Scrolling your scroll wheel just zooms in and out. So if you want to zoom in and then move over down to something that you want, you can do various clicks like that, or scroll back out. Holding the right button down doesn't really do anything. That just highlights a bunch of things. If you want to rotate, you need to click the scroll wheel first and then hold down the right button, click, and you should see this kind of rotating arrow icon come up, and then moving your mouse around should be able to rotate it around. So you should be able to see something like that. And if you release while moving, it'll keep it going. And then what you should be able to do is either just click to stop it, and then you can either move it around or rotate it again. You zoom in, rotate, zoom in, da 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 da. So make sure you know how to see it. The other one, Inventor, I believe the rotate is on the left click. So if you're really wanting to look at something, that's probably the easiest to do. I always just use the CAD navigation. It's the easiest, I feel. The buttons are a little bit tricky at times, but I feel it's the easiest in terms of when you're working and stuff like that. But whatever you're used to. So exit out of there. So we'll open up this one here, where we back back where we were before. All right, so you go up to here. These are called workbenches, I guess. So there's a different number of workbenches. Usually when you start to make an object, today I believe we'll make a pulley. So first step is you're going to make a sketch, right? And so depending on what you're doing, you want to choose your workbench to kind of correlate with the work you're doing. So if you're building parts, or if you're just going to do some sketching, you can do that. That'll bring up all the tools necessary for sketching. I usually just like to run complete, so it kind of gives me everything, and then you can arrange it however you like, put things where you want them, stuff like that. So just going to kind of move a few things around here. I always like my sketch stuff at the bottom here, and then some of my revolve and extrude tools here, and then these are my Boolean operations here, and these are just creating objects and a bunch of other tools that aren't really necessary at this point, but maybe we'll get to them in later tutorials. So first off, you're gonna create a sketch. So you can either click the button to create a new sketch, or I think you can go up here and create new sketch through your menu, whichever one you want. I think you can do it two ways. So I think you can either select a face and then start sketching on that face, or the way I usually do it is just start with a sketch, so create new sketch, and then you map it to the face later. So so once you click that, you decide what plane you want it in. For example, this can be important. In this case, it's really not. For example, if you want it to rotate about the x-axis, then you want to make sure it's in the xy plane. If you want it to rotate about the z-axis, then you're going to want to sketch in the yz plane, and vice versa. So I'm just going to choose the xy plane. You can also choose an offset. So if you have an object there and you want to maybe make a sketch further out from the object that's not at the origin 000, then you can choose an offset there, and the offset will be essentially in the missing coordinates. So in this case it would be in the z direction, so in and out of the page. So click that. You got your grid here. You can choose your grid size. I think this is pretty sufficient for what we're doing. So as you can see with the scroll wheel, it can zoom in and out, move side to side. Red point there is your origin, so that's going to be the center of everything, I suppose, at this point. So if you go up here, you can choose different views to get back to, but generally this is the plane that your sketch is on. So if we go up here, you'll see our sketching tools. So these actually make lines for your objects. So this will make a straight line, this will make an arc, a circle, this will make a bunch of lines without having to reselect each time. This will fillet between two edges, and this will trim. And this creates, you can link an edge to external geometry, and this actually makes lines into external geometry. So over here, these are your constraints here. Maybe I'll move this up and out of the way so it's a little bit easier. So these are the only tools we're going to be using for Sketcher. These are all the constraints here. So constraints, as I don't know if I said this before, but constraints, they're used to tell the computer exactly what object you have. So if you make a circle in here, the computer doesn't know what kind of circle it is. So you can make, millions of different circles of different sizes in different areas of your sketch. So you need to tell the computer exactly where the circle is in the sketch, and then you need to tell the computer how big the circle is in the sketch, and that's the only way it could make an object from that circle. So you can use constraints to help tell the computer exactly what you're trying to draw. So over on the side here, this is kind of your view bar here. So this will in the solver here, this will tell you if you have missing constraints or not. So It'll kind of help you there and tell you if it doesn't know something, but it won't tell you exactly what it is, so there can be some difficulties with that. This is your grid controls again. This will show you all the constraints that you have applied, and I think this shows you dimensions or something like that. So we're going to start with a pulley. I'm going to click this one right here, which is the Polyline one. This essentially, you can, I think if you cycle space or something like that, or no. Oops. Anyways, there is a button here you can cycle. I don't remember which one it is to change it, and you can actually cycle through these, but that's not really important. So right now it's just set for lines, so you can click anywhere on there. You can make a line, but as you see, it doesn't end it there. It allows you to continue going, which is kind of handy. So we're going to kind of make the basic cross section of a regular pulley. It looks something like that. So as you can see, it's already started to put constraints on here for me. So these right here, these are indicating that these are vertical and horizontal constraints. So this line, no matter where it is, it's always going to be vertical, and this line, no matter where it is, it's always going to be horizontal. So it's kind of done that for me. If I didn't want those, I could delete them. I can highlight them. As you can see, they're over here, so these are horizontal constraints. If I wanted to delete it, I could just hit the delete key and you see it's gone. And now it can be kind of any angle it wants. But in this case, we do want them to be horizontal. And so you can go up here, you can select a line and then tell it to be horizontal, and then it will be. So same with these ones up here. As you can see, these two lines here that I'm showing, both those are kind of weird angles. I want them to be horizontal. So I'm going to click them both and just tell them to be horizontal, and it puts a constraint there, makes them horizontal. So nice and easy. This one is also horizontal, so that makes it nice and easy. So this is the cross section of the pulley here. So this would be where the shaft would go through, and we're going to rotate it about this axis, which is going to make the object. As you can see over here, there's 12 degrees of freedom. So the computer doesn't know exactly what object you want. So obviously you can see that these can move around. That kind of indicates that there's degrees of freedom there. So when this gets down to 0, then you're okay to extrude. So you really, the whole idea about the sketcher is trying to fully constrain your sketch so that the computer understands exactly what you want. So in my pulley, we have a circular arc here instead of a V cut. So I'm going to go ahead and delete these lines here, and we're going to make a circular cutout here. So you can either use the circle tool, make a circle there, and then maybe cut one of the sides off, or you can use the arc tool, which is a lot nicer. I'd recommend that. And I want it to be centered on here. So I click where the center is, and then I can draw my arc like so. And so that's nicer there. As you see, these never connected fully up, or I never tried to. So what I want to do is I want to tell this to be on there. So you can do the point constraint, I guess. So if you highlight both points and click right here, this will create a coincident constraint. So these 2 points will be coincident. So if you click that, you'll see that they're now together, and I've created a closed structure. So that's another crucial thing as well. Is, your sketch has to be a closed loop. If it's not closed, then technically you're not creating an object. It'll run into errors and a bunch of stuff, or it might not even allow you to even extrude for that matter. So you got to make sure that you've got a closed surface. So as you can see, you can either check by zooming in, on each corner, making sure that they are connected. You can move things around, make sure that they are all connected. So that's pretty important. You can see that these are all connected as well. So so as you can see, there's quite a bit of degrees of freedom here. So we're going to start defining a bunch of things. We got the basic shape, but now we're going to start throwing in some dimensions. So to dimension things, it's usually best to go off the points themselves, not the lines. So if I want to define the height of this line here, it's probably best to click that point or this point, either one, whatever one you want, and give it a height. And maybe I want the inside diameter to be 20 or radius to be 20 millimeters or something. So, and you can kind of move that around, get it out of the way. You know, you can take a picture of this later if you need it for dimensional purposes or something like that. So there's one dimension there. As you can see now, this line won't move up and down. So that means it's constrained to 20 millimeters in that direction. So as you can see now, I've only got 10 degrees of freedom. So what we'll do is each constraint will essentially eliminate a degree of freedom, and hopefully we're going to get down to 0. So we're just going to go about dimensioning this. So want that. Maybe I want that a particular height as well. Maybe we'll do 40. Obviously, if you have a schematic or something, this would be the time to look at it and get those precise measurements. For now, I'm just going to put in random stuff because I'm not really concerned. In this case, I think I'm going to want to make most of this symmetrical. So there's two ways to go about this. You could try to define each one of these, you know, do a dimension, do that dimension there. That can be a little bit tedious. So what I would tend to do is there's what's called a symmetry constraint. So if you pick any 2 points and a line, it'll make those 2 points that you selected symmetrical about that line. So if I pick this point, and the center line, and hit the symmetry button, this is to create a symmetry constraint, it will always make sure that this point and this point are always the same about this axis. So it'll mirror them about the axes. So you can see that these two are, maybe I'll move this out a little bit, are greatly different right now. So if I select that point, I want these 2 points there to be symmetrical over this axis. And if I make a symmetry constraint, you'll see that they are now. And so no matter what I change this to be, so if I make this 10 millimeters, the other side will always be the same. So there's, you know, you can see that it's always going to be symmetrical, which makes things a lot easier. So that's one thing to consider when designing things, especially if they are mirrored or something like that. You can really make your sketching faster by doing that. So there's one there. So we're still missing a few things. Obviously, the width of this is not defined, and you can kind of tell because I'm moving it around. So I'm going to define a width here. And there are negative coordinates depending on how you define it, because I guess it is dependent on a Cartesian system. So now you see that I do that, I can't change the width anymore. So to define diameters, instead of using the dimensional tools, you can use to define a radius. Let's go 15 there, some nice round numbers. Also another constraint we can throw in here, as you notice, most of the time you're going to want these to be tangent, right? Or perpendicular, whichever one you want. So you can click the circle and click the line, and you can use the perpendicular constraint, and that'll make their meeting point perpendicular. So that makes things really nice. We'll put that same constraint over here. Oh, but then it threw an error. So if you look over here, it's telling you that one of them is redundant. And the reason that this one, making this 90 degrees, is redundant is because we've already imposed a symmetry constraint. So whatever we do on this side, we're technically doing on this side. So if you give the same parameter to constraints, it confuses the computer essentially. So you don't want to do that. If you ever do that and it throws this red error, you can it'll tell you which constraint is redundant, and so you can either select it out here, or you can go down to your constraints and you can search for number 30 and you can delete it, and then you'll see that it's really happy. So as you can see, we're really close. We've only got 1 degree of freedom left. And so sometimes this can be tricky to find. So if you're not sure which one it is, the best method I find is just click on things and try moving them around. If they don't move around, then another way you can go about it is go to each point and you can click lock. And then as you can see, it found one of the constraints, but the problem with the lock method is a lot of the times it'll put in redundant constraints, but you just delete the redundant ones, and eventually it will, if every point here was locked, then the thing would be fully constrained. So a lot of them would be redundant and maybe even conflicting, but essentially that's one way you could go about it. The other way is just to click on stuff, move it around, and see which one. So the one that we were missing happened to be a height constraint, so I'll just maybe go back to where we were. So before we were with one constraint, so the way we could have found that is we can see that this can move up and down. So it's like, okay, we need to define a height here. And so once we define the height, it's happy. Put in a measurement, and it's good to go. So once everything is green, and you go over to the solver and it says fully constrained sketch, then you know you're in the good. And so you can close, got to make sure you close Sketcher. And so now you're left with your sketch, and you got your sketch over here. So now what you're going to want to do is you want to make an object from this sketch. So there's a number of things you can do. You can make a pad, you can make a pocket, which is like a hole, or you can revolve. So let's say that we made a pocket. So let's take our sketch here. We'll select the sketch that we want to extrude, and we'll click pocket. We'll click OK, and you can see that it's extruded it 10 mils exactly. And so you can adjust the pad. Maybe we'll go 60. And so you can see that that's making a kind of a box shaped thing out of our sketch. And we can only really extrude it in the Z direction because the sketch is in the YZ plane. So that's the extrude there. What I really wanted to do though was to revolve it. So back to our sketch here. We'll click and get it where we want it. That's one way you can do it. You can make a pad, or you can make a pocket. You can only do this if you have another object to make a hole in. We'll talk more about that later. We'll come back to that one. Or revolving, which is what we wanted to do. So I'm going to click on my sketch, and then I'm going to click revolve. I'm going to go over here and we're going to select the sketch. So right now it can't really do vertical sketch axes, and that's because we're symmetrical about that sketch. So one thing to remember is when you're making a sketch for a revolved object, you can only make that object on one side of the axis. If you made the object on both sides of the axis, then you'd be technically revolving through it. You'd be revolving the thing through itself, which would throw a shit ton of errors. So don't want to do that. That's why you notice that we've only drawn one side of it. Like the axis is down here essentially, and we're going to revolve it around that axis. But you notice that I didn't draw another one down here, and that's because it would revolve the one through the other, and that would just mess everything up. So, and that's why with the vertical axis, right now it's trying to revolve it about this axis. And as you can see, there's an object on each side, and that technically revolves through itself, and that's not allowed. As you can see, no revolve has occurred. There's nothing there. If we click the other axis, the horizontal, you'll see that it likes it. That's okay, and it does it. It draws it for us, so renders it. So another thing to keep in mind is you only draw the one side that you want to revolve, and then you'll revolve it the entire 360 degrees back to start. If we had something else on the other side here, then technically it would revolve through something that's already been rendered, and that just throws a whole bunch of errors. So when you're happy with that, you also don't have to revolve at 360 degrees. Maybe you just wanted half of this. So you could do, 180 degrees or something like that, or maybe you only need it 25 degrees or something. You can make a pie slice of something if you need to, chucks or something. So other things to consider when building other things, you know, may be easier just to revolve something over a certain angle than it would be to try to extrude a triangle sketch that you've drawn. So there's always so many different ways to build objects, but you generally always want to try to think about the easiest way, the one with the least amount of steps that's going to take the least amount of time, because time is money. Alright, so now that you got your object here, it's starting to look like a pulley. Maybe your sketch calls for, you know, maybe there's some objects in here, something like that. And say you wanted to maybe cut something out of this surface. So you've got this object and you want to make a cut out of it. So and maybe it's really complicated. Maybe it's something that's not really easy. So maybe we'll give that a try. Do something fun with that. So what you can do, since I'm cutting, I'm going to do another revolve, but I'm going to cut kind of out of like a dish. Cut a dish out of this. You'll see in a second here. As you can see, when I click back to here, the object itself is kind of in the way of everything else. So if you want, the object you created here, which has been called revolution, you can rename it if you want. Should be right there. You can just call it pulley if you want. You can rename it whatever you want. Usually I'd only name it at the end when you're done, because if you do fillets or chamfers or something like that, it creates a new object each time, so the old one just kind of gets put behind. So but if you click on an object and hit the space bar, you can toggle its visibility. So each time you hit the space bar, it's just going to toggle it on and off. If I toggle the sketch here, I can turn the sketch on and off. So if I had the pulley, just wanted to see the pulley without the sketch, then you can see it's there. If I wanted to see the sketch, just toggle it. There it is. So in this case, I just want to see the sketch. I don't want to see the pulley. And click my button to orientate here. And so I'm gonna, at this point, I want to make kind of a weird cut in here. So maybe it'd be kind of a weird S with a bunch of, you know, complicated curves or something like that. That'd be really hard to make without a revolve. So we're not going to edit this sketch. We're just going to keep it, because it can be more complicated to try to constrain something with that funny looking thing in there. So a lot of times it's easier just to make two sketches and cut one from the other using what are called Boolean operations. So what you're going to want to do is make another sketch. So we'll go create new sketch, make sure it's in the same plane, press OK. So we're back to Sketcher here. We can't edit this sketch. This sketch is just kind of there, so I know what I'm drawing over. And so I think I'm going to make some really fancy curves in here. So maybe I'll do an arc like that. Maybe do another arc back kind of like that. And maybe do another weird arc like this. Something really crazy like that. And maybe we'll tie it all together like this. Something like that. And then see, at this point it doesn't really matter what's outside. You just got to imagine this minus this object here, right? So this whole all this outside here will just disappear, right? What I'm really concerned about is the kind of the contrast between these two. Like if you minus, this is going to be the new edge here, right? And so in order to constrain this, since there's so many centers and stuff like that, I'm just going to click all the centers and I'm just going to lock them down. It's probably the easiest in this case. So just hit the lock button, which just gives a dimension for the centers, since I like all these. And what I'm going to do is just define all the diameters that are there, because I really like this shape and I'm not really concerned with the dimensions. If you are concerned, you can certainly type them in. And so you see I've still got 1 degree of freedom here. As you can see, it's that one there. So the thing that could define that could either be a height, so I could probably constrain it with a height, or even, as you can see, the length of that line is changing, so I could click on that line and give it a dimension. As you can see, the sketch is fully constrained, so I'm good to go. Once it's fully constrained, you're good to go. And so now what I'm going to want to do is make an object from this that I can minus from my previous object. So I'm going to get rid of that sketch. I'm going to pull up my pulley. And what I'm going to want to do is make an object from this new sketch and minus it from this object. So I'm going to hide the pulley for a second, and I'm going to revolve this just like we did before. As you can see, that's around the wrong axes. That's not the axes that I wanted, and as you can see, since there wasn't an object on the other side of the axes, or the object didn't cross the axes, it revolved. It didn't mind that it was revolving. So that's not the one I want, though. This is the one I want. So as you can see, this is a really complex surface here that I wanted on the inside of my pulley. So I like that. I'll pull up my pulley now, and as you can see, the two objects kind of cross over one another. And so what I want to do is minus this object from, or sorry, I want to minus this object from this object. So this object will remain, but with kind of the imprint of this one. So in order to do that, you're going to use Boolean operations, which are up here. So these are all the different ones here. This one is to merge two objects. So if you have two objects that you want to fuse together. Oh no, sorry, I'm not quite sure. Oh, it's just run a Boolean operation, sorry. The fuse one is right here. So this one, if you wanted to fuse the two together, you'd use this one, make it union. I want to minus one from the other, or make a cut as I call it. I will use this one, which is the one we're going to use right now. And say there are several instances where you can have two objects and maybe you only want the overlap of the two. So the object that is created only when the two overlap. So that can be another tool to make really intricate and advanced objects, is using just the intersection space. In this case, we're going to just make a cut. So you always select the one first that you're making the cut from. So in this case, we're going to make the cut from our pulley. Right? Most of the pulley is still going to remain. It's just going to be, the revolution is going to be cut out of the pulley. And so you select the pulley first, then holding Control, you select the revolution second, and then you simply hit the cut button. And as you can see, that interesting shape that we had has now cut out of our pulley and has made a really complicated surface, as you can see. And if I turn off my draw style here just as shaded, you can see it's a really advanced surface there. So something that would take a really long time to try to draw out or cut out by hand. So using revolutions can really make a difference. So maybe I'll just show that one more time there, just to make sure everybody's on the same page here. So we've got our pulley there, which is like that, very normal, hasn't been cut yet. And here's our revolution, and that's the advanced face that we want on our pulley. And so in order to make that cut, you're going to take the pulley, which is the thing being minused from, and you're going to take the revolution and you're going to cut the revolution out of it. You simply hit that and you can see there's our really advanced surface. If I did it the other way, so if I had the revolution and the pulley, let's say I got these mixed up and I selected that first and then did the pulley, you'll see that only the other object remains and it's going to cut what the pulley would have taken away, so it just had a flat surface. So that's obviously not what we wanted. What we wanted, start with the pulley, Control, revolution, and then the cut button. On the Mac, I'm not sure what it is, if it's Control or I don't remember the other button. Whatever one you use to, keep highlighted whatever you select. And then that. And just go to view here, get my old draw style back. So as you can see, there's the advanced surface that we wanted. So very nice. Very nice. As you can see, it's created a new object from it. So this object is made of two things. It's made of the pulley and the revolution. So it shows, you know, what the cut is made from. So if ever you need to go back, say I didn't like the way I did that, you can just simply delete the cut, and the old objects that the cut was made from will still exist. So that is a cut. So now what we're going to do is we're going to do another cut, but we're going to do it with a pocket as opposed to doing it with a with another object. So there's kind of two ways to make cuts or holes, or you know, shave things off, or whatever you want to call it. So now we're going to make some holes for this pulley. So don't want it in that plane there, but I do want it in this plane here. So I'm going to make the holes kind of like this, if you can see my mouse there. So right now what I'm going to do is we're going to make another sketch. But we're going to note the axes that we want to make it in. So we want to make it on this surface there. So we want to make it in the ZX direction. So I think you can either select the surface, and you can no, I think that's just a SolidWorks thing, to be honest. I'm not quite sure. So anyway, so you're going to make a sketch. So you go back to your sketch button. You're going to make a new sketch. Decide the plane you want it in. I want it on the ZY plane. And then you would click OK, or if you want an offset. In this case, doesn't matter the offset. It's not really going to affect it. The offset would affect it if we were going to rotate, but we're not. So oops, I must have selected the wrong axes. So if you do select the wrong axes, I think you can change it. No, you can change the offset. I don't know if you can change the axes. So just delete it and try again. I thought you could. Yeah, okay, so that's how you do it. So if you want to create a sketch on a surface, so maybe I'll just delete that for a second. Alright, so it is just like SolidWorks. So you can either make a sketch and then map it to a surface, or you can select a surface and then the sketch will just be on that surface. So that's probably the easiest way. So I want to put the sketch on this surface there, so I'm going to select the surface. It goes kind of a semi-green when it's selected, or you can see it here. And then you'll click the Create New Sketch button, and it automatically creates the sketch on that surface. So you can see it's not centered, but it's well, it is in this case. Or no, well, that's where it's defined our origin. So you can see it's not on the center of the pulley, but it's on the face. So that's what we're going to do. That's where we want to put it. So in this case, I'm going to make some holes. So they're going to kind of look like this, but it's going to be kind of an arc hole. So let's see if I can do this. I'm going to use my arc tool. I'm going to make the sketch just as before. I want those connected, and I want these connected. So it's kind of working there. I can kind of drag it to make it work. I'm going to make this smaller. So now here's a great case for the snip tool. So first I'm just going to make these the same. So another constraint is to make things equal or the same size. So I've made these two circles equal. So if I define the diameter of this one maybe as 25, it'll immediately change the other one. So that's really nice. So for the snip tool, I'm going to want to cut out these circles, right? Because I just want this to be one closed surface. And that's one thing I should have mentioned earlier as well. You don't really want multiple, closed loops. You just want one big one. That's probably that's the best way to go about it. So this is the snipping tool here. So you simply click on the thing you want to snip. As you can see, it's deleted out the portion that I didn't want. Same with over here, so it's kind of made this one surface that I can use. So and that's exactly what I want. So now I'm going to constrain it. There's a number of things I want. I want these to be tangent, which means that this to be parallel with this as it comes in. So you can click these two. You can use the tangent button or the tangent constraint, and it'll make a tangent constraint there. Just to kind of give you an idea of what that actually does. You can see that these two are not tangent. They're not straight, so I'm going to make them tangent. As you can see, it makes them perfectly tangent. So I'm going to make these all tangent. Oops, no, I don't want that. I want that one tangent. I want that one tangent. So I got 4 tangent constraints there, which is what I want. Alright, so, but there's a redundant constraint there, number 12. It doesn't like that, so I'm going to delete that one. Oh, and that's because I've told these circles to be the same. So since they're the exact same circle, by by logic, this always has to be tangent as well if these 3 are tangent. So that was a redundant constraint, so I've deleted it and now it's happy. So there's still 30 degrees of freedom here, which I can see by moving it around. So obviously the height of this or the radius isn't defined, so I'm going to define that radius there. Make it a 85, maybe a little bit smaller. That looks good there. This one I could define, but since I've already defined the radiuses of these circles here, this one's kind of already set in stone. This one can't change because these circles are already set, and I've given it this dimension as well. So, by math, this needs to be, 110, right? And if I try to give it that dimension, or sorry, it's oh, this is radius here. Sorry, so it'd be 50. Yeah, 135. If I try to give it that, you're going to see it doesn't like that redundant constraint. So just if you ever run into those, just delete it, make it happy. So I still got 2 degrees of freedom there. As you can see, those can move. That can move. So maybe I'll set a distance between these 2 points here that'll keep them from moving. I'm just going even 100. So now, as you can see, now just where it is on the circle needs to be defined. So maybe I could say this point right here needs to be like that. It liked that. That was okay. Also, what you could have done is went, okay, maybe I'll just constrain it to that line there. It liked that as well. So there's a number of ways you can constrain things, but just whatever way works the best, or depending on the dimensions, you may only be able to constrain certain ways, right? So you may only be given a few dimensions, and you may have to use various tangent, parallel, and symmetrical constraints in order to just get it fully constrained. Excuse me, working with those dimensions that you've got. So if you're happy with it and you're fully constrained, then you're good to go. So now what I'm going to do is I'm going to close the sketch, and I'm going to make a pocket from that sketch. So I'm going to click on the sketch, and then I'm going to click create a pocket with the selected sketch, which I've already selected, and it'll bring up the pocket parameters. So as you see, it's already started to make a pocket. In this case, it's only dimension right now, so it's only pushing it in 5 millimeters. In my case, I want it through all. And so that gets rid of the length and makes this big hole of the shape that I've predefined. So that's very nice. I like that a lot. I'm happy with that. And so I'm going to click OK. So the nice thing about working with sketches is if you don't like something, you can always go back and just edit the sketch, and it'll edit all the objects that are built with that sketch. So say I wanted to change the size of that hole. All you'd have to do is go back to the sketch, reopen it again, and you could change one of your parameters here. Maybe I Maybe I wanted these circles bigger, so I could go with 30 or something. So it makes it bigger. Maybe I still want it a little bit lower. And so it'll make the hole already. So as you can see, that's already bigger and it's already made. And if I'd done a pattern or something, it would have adjusted all the pattern as well. So another benefit to making pockets is pockets are a polar. You can make a polar pattern feature with them. So if I just made a cut, cuts don't really seem to fall. This feature can't recognize cuts for some reason, and so you usually always need to make a pocket in order to duplicate it several times. So so in this case, I'm going to select my pocket. Or sorry, I'm not going to select anything. I'm just going to deselect everything, and I'm going to select polar feature, and then it's going to choose exactly which feature I want to revolve. So as you can see, there's only a couple features here that it's recognized that it could potentially revolve. So, or polar pattern, sorry, is a better term there. So the pocket is the one that I want to, which is the hole I just created. So I'm going to click OK there, and as you can see, the menu comes up, and you can define a bunch of parameters here. So you can choose the angle that it occurs at. So maybe I wanted 180 degrees or something. Oh, that doesn't really mean, maybe 30 degrees or something like that. It doesn't quite like that because it overlaps. Maybe go 90 degrees. So yeah, so you can define an angle there of the two occurrences. Or you can change the number of occurrences. So maybe I want 3 occurrences. As you can see, there's 3 there. Maybe I want 4. And you let it render up. So you can make as many as you want, assuming that they don't overlap. When they overlap, it'll give you this big error. Big red stuff will come out. So 3 seems to be enough for me. 3 looks good. Once you like it, you click OK. And so now you've got a polar pattern. And so, as I was saying earlier with the sketches, editing these advanced structures become easy, right? So let's say I still didn't like the shape of those. I could go back, and maybe I just wanted them to be smaller. And if I edit one, since everything else is built off of it, everything changed. And so that's one really nice thing about working with those. And so as you can see, they're all smaller now, which just by, since the polar pattern was built off the pocket, and the pocket was built off the sketch, by changing the sketch, I'm going to change the pocket, and I'm going to change the polar pattern. So nice thing about Sketch is you can go back and re-edit a bunch of things. So what else can we do to this? We can do a bunch of fillets and stuff like that. So fillets is kind of like putting an edge on things, or a bevel, or a rounded bevel, or something like that. So most all edges can be done. Really complex edges like these ones, there might be some difficulty, but and especially with these ones, you may have to select a whole bunch of edges, or the full circle of the edge that you want to be beveled. So let's say I wanted these to be beveled, I could go like that. Okay, apparently that's too big, it didn't like that, so maybe I could go 0.1 or something like that. Maybe that'll be okay. Yeah, so it likes that. If it disappears, that means that it can't make it, it's too big, or it's just not going to work. So maybe we'll go 0.4. See what that does. It's still too small for me to see. No, it's still too small. It apparently doesn't like 1 millimeter. 1 millimeter is too big, so. Oh. But anyways, yeah, it's too advanced of a surface because we made some really crazy curves on there, right? So, or maybe I just need to select them all. Oops. Let's see if I select them all, if it'll make it. No, see, it's still doesn't like that. Maybe if I do a rounded surface. No, it doesn't like that. Okay, so too complicated. But with any of these like nice straight edges, you can make a bevel on them. So if I take that one and hit the fillet or the chamber, you can see it makes it, and you can set the size of it. So you can either make it 5 mils or 3 mils or 2 mils or something like that. So you can change it. If you make it too big or it can't make it, then it either won't change it or the object will disappear. So 5 seems okay with me. As you can see, it makes another object from the polar pattern. So that's kind of nice. The only thing I don't like about chambers is you can't really do a polar pattern of them. So if I wanted to bevel, these are nice straight edges, so it should be able to bevel these quite nicely. As you can see there, it does. Should be able to do maybe like a 3-4 mils or something. So you can see that's nice. That's nice. But the problem is you can't polar pattern it, which is really unfortunate. And I think that's just a limitation of the program itself. So you would have to do each one, and then in order to change it, you would have to change each one individually. So that can be a little bit of a downside, especially if you're doing sprockets or something like that. But there's ways to get around it, to do things in big ways. So as you can see, each time I do that, it creates a new object from the old objects. So that's chambers for you. You can also make, maybe we'll go back and we'll really show the abilities of the polar pattern here, especially for gears and stuff like that. It makes it really nice. So I click that, and I'm going to make a sketch on that surface there. So maybe I wanted to make a spline or something like that on this object. Then a polar pattern could be really easy or really nice for that. So make a spline. It might look something kind of like that. You imagine this being cut out, right? So now just define this however you want. So I want this kind of symmetrical about this axis here, so I'm going to do a symmetry constraint. Same with these two here, symmetry constraint. As you can see, it makes it nice and symmetrical, and I'm just going to lock these bad boys in place, which will keep them the size they are. Things fully constrained, you're good to go. So now I'm going to take that and I'm going to pocket it. And as you can see, it's pocketing into this object here. So maybe you want your splines only, you maybe don't want them to go all the way through. Maybe you only want them in 20 mils or so, or maybe 40 mils, something like that. So you could either make a key cut with this, or you could make splines with them. So I'm going to make splines with them instead of a Woodruff key or slot or something like that. So now that you got your pocket there, you can take that. Sorry, I'm going to click polar pattern, and then I'm going to select that pocket. As you can see, it's created 2 instances. Maybe I want, maybe there's 30 splines or something like that. Let's try 20 and see if that'll fit. Sometimes it takes a little bit to render. So as you can see, that's looking pretty good. And I mean, one way to do this is, just to measure, if you had to do this from dimension, all I would do is measure the dimensions of the slot itself, and then just do the number of slots that are there, which should give you everything that you need technically. So looks like my core is heating up a little bit, not too much though. Yeah, so these renderings can be a little bit, depending on the system you got, can be a little bit heavy on various things. So as you can see there, I've got a really nice spline set there, which is really useful. This revolve tool, or sorry, this polar pattern thing. So that can be really nice. So say we wanted maybe a beveled edge or something on there. I think you can go back and hide this, and you could click. No, it wouldn't be pocket. You want to go back further, I think, or maybe the pocket. Yeah, I think you'd have to go back to pocket. I think you could select that edge there. And maybe chamfer it to, oops, that much. Maybe 2. I think if you go to the, no, it's created a whole nother object from it. So yeah, no, so that's one thing to really make sure that, you know, if you wanted something, you know, because each time you create an object, now that I've created a new object, I can only edit the things that are in the object. So now if I wanted to change the sizes of these, I wouldn't be able to do that because a new object's been created. The sketches that are contained that define these shapes here are back in the pocket or the polar pattern. So yeah, I think if I let's see, it might be okay. I don't remember now if that'll work or not. Oh, it's thinking hard. That's probably a good sign. So yeah, you still can actually, so that's good. And it's obviously all the objects that were created after are still good. So I contract my previous statement that you can indeed go back and still edit the sketches that define all the objects and the objects created from those objects. So that's really nice. So you got splines, you can make keys and the various other things. So I think that pretty much wraps up my tutorial for rotatable objects. Maybe I can open up. And so yeah, no. Yeah, so yeah, once you're done here, you make sure you save it. You can also edit the color of it. So if you side click on here and go to appearance, you can select maybe you wanted to make this out of brass. You know, give it kind of a brass color. Give you all your splines and stuff, and oh, maybe that edge needed to be filleted or something. You know, whatever you need to do. Maybe that edge needed to be filleted, that one edge, or you could get them all or something like that. If I was smart about this, I would have chamfered that edge before I made the pocket, and then that would have been nice and rounded. But that's part of the task of CAD work, is to plan your steps so that you got less work to do in the end, and you can make really fast drawings efficiently. And solid drawings that aren't, you know, solid object, you know, that are solid objects. So so if you did want to say you're happy with your design here, you checked all your dimensions and stuff like that, and you can check dimensions using this tape measure tool too. You can look at various dimensions between things and stuff like that if you really need to make sure that you've got what you've got there. You can do that. You can look at it a number of different ways. But if you're happy with it, you can export this. Sorry, you got to click the. You could export it as a .stl file or a .step file or a mesh or something like that if you want to throw it into another program. So what you're going to want to do is make it into an object if it's not already a solid object. And so you can go up to part, and you can convert it to a solid. If it's already a solid, it'll tell you it is. If not, it'll make a solid from it. So obviously the chamfer wasn't a full solid, and now we've got a complete solid object. So you can just hide the old one using spacebar. So now you can rename this whatever you want, pulley wheel brass or something. And so now that you've got that, and each time it creates an object, it selects a default color. So you want the brass color. So I click on that, and now what you can do is you can select the object. You can go File, Export, and you can choose any file to export it as. So there's your .stp or .stp file, step file, and there's your .stl file, which is a mesh format. So either those two are probably pretty good for 3D printing, or if you're sending it to a CNC or something like that. Obviously the file format will depend on the machine, but 3D printing and stuff like that I'm pretty sure uses those ones. Or if you're going into FEM analysis, and probably more likely step files. So just click it, name it, brass pulley, and go save, and you're done. So now if you go into your files, I'm trying to think where I was. It's probably, oh no, maybe in here. Yeah, it was in there. Okay. Go to your files. We're tutorial, and there's your step file right there. So obviously my computer doesn't really recognize it, but other programs will, like an FEM analysis or even this program. So if I make a new one and I want to open the step file, there it is. There's the step file right there, so it's ready to go. Alright, so that concludes our tutorial on revolving and basic extrudes. Next tutorial, maybe I'll do some of the same things, but maybe I'll make a sprocket or something like that to just kind of bring all of our techniques together here that we've just done and kind of encompass them into one. Later on, we'll look at a bunch of other techniques. They're pretty much all similar. They're just, maybe I'll just build a bunch of different things just to kind of give you ideas on how to go about doing things, especially more complicated things. So yes, we'll see you then. Cheers.